So here we have the 2017 coordinate geometry question. This is junior cert higher level, and we're given a diagram. So the diagram we're given in the question is a lot more accurate. I'm just after roughly drawing it out there now. But they label the lines Q or ST, and we're asked to match the line with its equation, and we're asked to do the equation of S. So the first thing, there's a formula for an equation of a line. The first one, the formula is in our log tables. So we have y minus y1 is equal to mx minus x1. So y minus y1 is equal to mx minus x1. And in this, this is to make the equation of a line. And then our point that we'd be plugging in is x1, y1, and m is our slope. But there's also another equation, y equals mx plus c. And when a line is in the form y equals mx plus c, well, if we let x equal 0, y is just equal to c. So c is the point where it crosses the y-axis. So c is where it, only when it's in the form y equals mx plus c, crosses the y-axis, and then m is the slope. So looking at these lines, this is in the form y equals mx plus c, so it just means that there's something attached to the x. So if we were to write y is equal to x plus 3, well, the thing attached to the x is the m, but there's nothing apparently clearly attached to it. So that means it's just 1x. So m is equal to 1, and m is the slope, so the slope is equal to 1. And then the point where it crosses the axis is going to be 0, 3. So it crosses at 0, 3, and there's only one point where lines cross it in the positive y-axis, so this point here must be 3. But I don't know yet which one is Q and which one is or. So I'm not sure if it's or Q yet. But I also know that the next line I'm given is y is equal to x minus 3. So I can see from that this m is 1, so it's just 1x, and then where it crosses the y-axis is 0, minus 3. And there's only one point where lines cross the y-axis, so this is going to be minus 3. So then the next line I'm given is I'm given y is equal to 2x. I'll just pull this up so we can see. Y is equal to 2x plus 3. So looking from that, the slope is 2. And then where it crosses the y-axis is 0, 3. So I know that y equals x plus 3 crosses the y-axis at 3. And this one crosses the y-axis at 3 also. So I have to then differentiate which one is which. But say the slope is equal to the rise over the run. So say if we had a slope like this, and it had a run of 10 and it only rised by 5. So then the slope would be the rise over the run, which would be a half. But say if we had a steeper line, and say the rise was 10 and it went across 5, well then the slope would be 2. So if lines are steeper, if they're more steep, they're going to have greater slopes. So one of these has a greater slope. One of them has a slope of 1, the other has a slope of 2. So this one here is steeper, so this must have a slope of 2. So this one here must be Q. And we were told in the question that Q is parallel to S. So the line that Q is parallel to, this is going to be also have a slope of 2. And we're so if Q is this steeper one, well then the other one must that has crosses the y-axis at 3, which is this one, must be or. And then we're also told another one, there's the line that also crosses at a minus 3 but has a slope of 1. Well, Q must have a slope of 2, and then or has a slope of 1. So the one that has a slope of 1 is parallel to or. So this one, T, must have the slope of 1. And we are asked to form the equation of S. So we can write the line in the form y equals mx plus c if we know the slope and where it crosses the y-axis. But we were told S is parallel to Q. So the slope must, parallel lines have the same slope. So the slope m is equal to 2 and it crosses the y-axis at the same point where t crosses it. So it crosses the y-axis at -3. So the equation of S will be y is equal to 2x minus 3. So I'm just going to write this in. Y is equal to 2x minus 3. So that's going to be the equation of S and the other lines. And then it says, use algebra to find the point of intersection of the line. So we're given two lines here. So y is equal to x minus 3 and then y is equal to 2x plus 3. So with this, to use algebra to find the point of intersection, so the point of intersection is the point where the two lines meet. Well, we can do simultaneous equations firstly, so we can bring the x and y's to the same side. So that'll be y minus x is equal to minus 3 and then y minus 2x is equal to 3. So then we have to get one of our variables to cancel. So they have to have the same number attached to them and opposite signs. So the y's might be easiest to cancel, but they're going to have opposite signs. So I'm going to have to multiply both sides of one of my lines. I'll do the top line by -1. Because if we multiply, if we do the exact same thing to both sides of our equation, it stays balanced. So -1 by y gives me minus y, -1 by minus x gives me plus x, and -1 by -3 gives me plus 3. And then the bottom line stays the same. So now I have minus y plus y, so that's going to be 0. I have x minus 2x, so that's going to be minus x. And then I have 3 plus 3, so that's going to give me 6. So now I have minus x is equal to 6, but I want what x is, so I can divide both sides by -1, and then I get x is equal to -6. So if I want to figure out what y is, I can just sub in my value for x back into one of my original equations. So say if I sub it back into equation number 1, I get y is equal to -6 minus 3. So y is equal to -9. So my point of intersection is going to be -6 minus 9. There is another way that we could have solved this. We can write both of our equations. So say these our two equations. Say this is an alternative way to find the point of intersection. If we write them both in terms of the same variables, so they're both in terms of y, they both have y is equal to whatever. We can let y of one equal y of the other, and then we should get the exact same answer as we did simultaneous. So if we let y of one equal the y of the other, and bring x's to one side, think this doesn't have an x to the other side, so that'll become -6. That'll become, so say if we bring our x's to this side, so that'll be -2x plus x is equal to 3 plus 3. So that'll be -x is equal to 6. So then we can divide both sides by -1 and we'll get x is equal to -6, and then we just have to sub -6 back into one of our originals. So say y is equal to -6 minus 3, so then we get -9 for y. So our point as well this way was -6 minus 9. So it's just a matter of preference which way you'd rather do it. And then we're told we have another part C. So the line L is a vertical line. So vertical just means straight up. It just straight up. If a line was horizontal, it would just be straight across, horizontal. It cuts the line y equals so x minus 3 at the point A. Cuts the distance. So I think it's looking. So first I'm going to draw my axis. So it so they're giving us the line y equals x minus 3. So that was one of the lines that that we were just after dealing with, x minus 3. So we can tell by that the slope is 1, and then where it crosses the y-axis is -3. So it's going to cross the y-axis at -3. So say it goes something like this. So this is, say, our line. So the vertical line cuts this at a certain point, And then it also, so if we wanted to draw the line y equals x plus 3, well, that's also going to have a slope of 1, so it's going to be parallel, but it's just going to cut the y-axis at the point 3. So it's going to cut it at 3, and we have a vertical line, and so a vertical line could have been in any of these points. It could be anywhere here, and then it cuts, so the distance between parallel lines is always going to be the same. The distance from here to here is exactly the same as the distance from here to here from a vertical line, and is equally the same as the distance from here to here. And then we're asked to find the distance AB. So what we can do is we can just get the distance between 2 points. So we can get we can just say, because it's going to be straight up vertical, it is climbed from -3 to 3, and it just went up, so it has a jump of 6. So 6 would be the distance, but I can get 2 points that are directly vertical on the same vertical line, and I can put say 0, -3, and then 0, 3, as long as they're exactly vertical, just right above each other, and then I can get the distance between them. So the distance is x2 minus x1 squared plus y2 minus y1 squared. So say if I call this x1, y1, and this x2, y2. So x2 is 0, so minus x1, so 0 minus 0. And then y2, which is 3 minus y1, so minus 3 squared. So then I get... so the square root, so 3 minus, so that's going to be 6, so 6 squared, so 3, that'll become 3 plus 3, so then I'll get the square root of 36, and that's equal to 6, and I got the exact same answer when they're on the same, when they both have the same x point, and I'm just going up. I can literally just count up how much the y had, but if there is a slant, I have to use the distance formula in order to get the distance. And that is our answer for that. Thank you.